Okay, so in the video we talked about three type of osmotic states. Okay, well actually let's recap just a little bit. We talked about osmosis, and osmosis is the diffusion of water through a semi-permeable membrane. Okay, it's a type of passive transport. Okay, and we talked about passive transport being the movement or the transport of molecules from an area of high concentration to low concentration. Okay, so a type of passive transport is osmosis, all right? And osmosis is the diffusion of water through a semi-permeable membrane. And this is explained in two ways. You can say that water moves from an area of high concentration to an area of low concentration. Or we can say that water moves towards an area of high solute concentration to an area, or from an area of low solute concentration. Now, if solute is kind of confusing you, there are two in a solution. There are two components. One is the solute, and that is what is dissolved in the solvent. And then there is the solvent, what the solute is dissolved in. Great example of this is salt water, where salt is the solute and water is the solvent. Now that we've talked about this a little bit, we're going to go with this first definition right here because I think it's easier when you're just first learning this stuff to think of osmosis as moving from an area of high concentration, or water moving from an area of high concentration to an area of low concentration through a semi-permeable membrane, just because the definition of we want to think of this as passive transport, and the definition of passive transport is when we move molecules from an area of high concentration to low concentration without the use of energy. Okay, now there are three types of osmotic solutions or osmotic states. Actually, okay, we'll just go with this one. Isotonic is when water moves in and out. And I also want to explain these just a bit differently. When we talk about hypotonic solutions, or when we're talking about hypotonic, hypertonic, isotonic. We're talking about solutions in relation to each other. So if we had a hypotonic solution, it has more solvent or more water than it does solutes. And hypertonic more solutes than water, and isotonic has equal amounts. Okay, when we're talking about these in relation to each other, and I'm going to pull up this worksheet and it'll make more sense to you. Okay, so here's this worksheet. And like I said, this is an osmosis worksheet. So two things that we're talking about here is we're talking about water, and we're talking about water moving through a semi-permeable membrane. It's going to move from an area of high concentration to low concentration. Okay, and I explain this two ways. Here is we talked about moving from an area of high concentration to low concentration. Okay, here's high water concentration moving to an area of low water concentration. See how we have 90% inside the cell and we have 80%, 85% on the outside of the cell? This is water is going to move outward, okay? Now, I also said that, and I don't want to confuse you with this, that it will move towards a higher solute concentration. Well, naturally, if you have um, the if you have a higher solute concentration, you're going to have a lower water concentration, or vice versa. If you have a higher water concentration, you're going to have a lower solute concentration. So I said it will move towards a higher solute concentration. So you see we have 10% solute here. It would still move outward to this 15% here. Okay? And the reason why it's doing this is because it wants to make these concentrations equal. Okay? Now, I also talked about identifying the types of solutions, isotonic, hypertonic, or hypotonic. Okay, well, these are, like I said, in relation to each other. Okay, so if we're talking about this beaker right here, okay, so like I said before, when we talked about these, we talked about hypotonic, hypertonic, and isotonic. Hypotonic is going to have more water than it does solutes, and hypertonic is going to have more solutes than it does water. And then the isotonic is going to be equal. Well, these are, when we talk about hypotonic, hypertonic, isotonic, I said we're talking about in relation to like a you know, the in this example we have a beaker and we have a cell in a beaker. We're talking about these in relation to each other. This wants you to identify the solution that the cell is actually sitting in. So this is actually, since it's the water is moving outward, this is actually, and we look here, we have more solutes than we do water here, okay, in comparison to this solution. So this is hypotonic, okay? But if we're talking about this cell, if it wanted to know if this cell was isotonic, hypertonic, or hypotonic, this cell would be hypertonic, okay? But don't worry about that for this assignment, and for the most part, you're going to be asked about cells, and the way I remember it is when we're talking about these cells, if this, I'll explain in this next one. Okay, so here we have one that's 40% and 60% solute, 40% water. Here we have 90% water, 10% solute. So, where's the higher water concentration? Bam, it's in the beaker. The lower water concentration is in the cell. So what happens is water moves in, okay? And we would call this um, a